Well, hello, everyone. I am Bill Wagner. I'm one of your hosts today for the .NET languages, managed languages, and runtime stand-up. With me also helping to host is Kathleen Dollard. It's a PM for managed languages. And we are absolutely thrilled to have Matt Warren here, who's a longtime member of the C# team. If we go way back, reading your blog post is how I learned how to create an iQuery provider, which might be the only series longer than some of Stephen Tobe's performance ones. But Matt's here today to talk to us about ongoing design work for union types. I'm really going to let you just take off from here. You can speak to how far along the design is, what we're still questioning, and what problems we're trying to solve, and we'll monitor questions and everything.
Okay, thanks, Bill. And thank you, everyone, for coming to listen here. I've never done one of these before, so I'm not sure how it works. But I kind of got a lot of attention last week by posting a document to C# Lang titled "Union Types," and I already knew this was kind of a favorite topic in the community. But I was posting it as a report back to the C# language design team on what the working group had been talking about so far. We were asked by Mads to give this document, and I didn't really think about it going out to the community, but it was posted there because that's pretty much how we run C#. We kind of do everything in the open. And I was really expecting to get so much attention. I was expecting to just kind of talk about the summary and get some questions from the team, and then we could go back and continue running the working group. But it does kind of look, the way it's written, like it's a proposal, but mostly it was just as a way to refresh everyone's mind what we were trying to do, and kind of change, reset what people were thinking about after we got the information or what we learned from having the separate working group talk about discriminated unions. So we spent a bunch of time just talking to each other and learning from each other. And there was a bunch of people in the group that were from C# language design or represented other teams within Microsoft that had either some vested interests or some ideas about how the language could help them and their product, and how that might overlap with just the community in general. So we took a look at how existing discriminated unions were being used inside Microsoft and outside. Now, of course, C# doesn't have a concept of discriminated union, but explicitly, but there are things that people use in C# that are kind of like discriminated unions, but the language doesn't really understand them as being discriminated unions. So we were talking about how can we make things that people are already doing work better the language. And the primary thing that we're talking about to improve was using these types in pattern matching. And when I say pattern matching, it sounds all highfalutin, but it's really just how does it work in a switch statement. Some of the examples we had were, if you think about it, an enum is like a discriminated union. It's just a set of states that a value can be in, and you use them in a switch statement easily. But an important aspect of pattern matching that we kind of take from functional language is the sense of exhaustiveness. That when you do a switch in C#, it's like doing a switch in C or C++. It doesn't really know that the set of things in the enum is exhaustive because of how enums are defined. And they're really just kind of a mask on top of a number. And since you can send different values into that set, it's not really closed. You can say, oh, I've got an enum called kinds, and you can label a dozen of them with different names, and then someone can assign a number that doesn't match any one of those into the enum. And so we want to try to solve that. How can we make pattern matching work well with things that are like union enums? And then there's, of course, type hikers. People in object-oriented languages like C# kind of solve the concept of a discriminated union often with just making a small, limited, or shallow type hierarchy, where you have a base class that's probably abstract, and then you have a number of other derived types. And then when you want to operate over them, you now use a type switch in C#. So that's pretty straightforward. But again, you don't know that that is a closed set of types at the time you compile. So the switch statement can't help you and say you missed a case. You always have to have a default. So we wanted to solve that problem too. We want to be able to say, hey, I know you've already written type hierarchies and they're kind of like a discriminated union, and make the language understand that that's what you meant, and you really want exhaustiveness when you switch over them.
So what kind of stuff do we come up with here? What are the ideas behind this? You know, like from some of the earlier discussions.
This was examining about what people are currently doing and how can we take what they're currently doing and make it work better in C#.
And so there's two sides of that. And there's one side is that, yes, we're looking at what people are doing today in C#, which is the things that we know will have value to them because they're already doing it. And there's also what's going on in other languages. And we have a question in the chat on that, which is how we're thinking about F#. And I'm going to just extend that to say TypeScript as well. So just because I know there's people here that have their own views on discriminated unions, maybe we could comment on how we think about other languages just at the beginning of this. And again, I want to stress, as Matt did, that this is a discussion, not a proposal. We are early in this process, and we're coming early just because we thought you'd want to know.
And this isn't a complete discussion. This is just a point in time and things that we've talked about so far. And if you've looked at the document, you'll see eventually gets into implementation choices. And they're just a kind of a handful of things we had thought of so far as possible implementations of, you know, things like discriminated unions. We did talk to developers from the F# team to see how they represent their discriminated unions and see if that's the right model. We don't know. We don't know yet, but we do know that there are examples of discriminated unions in the wild in other languages. We also are quite intimate with the design of TypeScript over in the C#. And so we know that TypeScript has a union type model in the type system. And we're like thinking about, well, that's something that we would like to be able to do too, and to some degree. We're trying to figure out what of that is possible to do, and how we would implement that as well.
Well, you said, yeah, and you said something kind of interesting. I think that's important as we started this, where you talk about this idea that whether it's an enum or a type hierarchy or whatever, that we want to, the language should be able to say you've covered everything. There are no types that could be here that you don't have. There's no values you didn't cover, and that's that switch expression and switch statement thing. Yeah, I kept reading and I like the idea of getting the compiler to fix this. I've written so many. There's the default throw not implemented exception because we found some value we didn't know about, and then we catch it much later than I'd like when somebody adds a new case. I don't know how you want to kind of go over that in different ways.
But there's an example in your document. Do you want to take a look at? Didn't you show that in your document?
That explicit case,
or something like it in terms of
a switch statement that doesn't
general scenarios. Yeah,
it's the switch statement is already comprehensive. It already covers everything, and so you don't need the default, and you don't need to worry about what happens on the default, which is the important thing.
I don't know if I have an exact picture of exhaustiveness in the document, because my audience writing the document was the C# language design team, and we're pretty much already reversed in that concept, and so I wasn't trying to really educate anybody on that there at the time.
Okay, fair enough. Yeah, the audience, what we're sharing with the audience today is something that was designed for the language designers, and so we certainly want to make it accessible to everybody. And so, talking about whatever questions come up is super super helpful here. We have a lot going on in Interop in the chat, and so I think I just want to generally answer that. When we have a proposal, the proposal will include how it interops with other languages. That is why we're including Vlad and others from the F# team early on, and we will consider VB, and we will have that be part of the proposal. I can't say at the moment what that's going to actually look like, and I know that the F# people, kind of felt a real stab when records don't interop nicely between C# and F#, and we are very aware of that. However, for records and for DUs, we are going to design the right thing for C# and then we're going to get the interop. Vlad's looking at this, and there's nothing right now that causes him a lot of concern. So if you're in F#,
that sometimes things that are idiomatic for F# won't be idiomatic for C#. And when we look at designing something for C#, it might end up looking different in its implementation or surface area than something that was designed by the F# team for F#. And so it would have been nicer if we were all working together at the same time and coming to a common thing. And obviously, there's benefit if what we do come up with meshes well with F#.
Right.
But I can't say that we're at that point of making decisions like that yet. We're just kind of exploring the space right now.
Right. And I do think that I just want to acknowledge that the questions are more about interop than they are about the actual semantics in C#. I think everybody kind of for sure gets that C# is going to look like C#. But we will be considering the interop with F#. And I'm optimistic it'll be better than records, just because I know it's a focus on the team. The F# team is very interested in making that interop story good.
Mm-hmm. I think there's an interesting comment there from Obena also. Please ensure it's idiomatic C# and F# concerns should be secondary. I think that was a lot of what I took away from the discussion. I think that's true, but I'd say it's probably a close second. I think language interop is important.
And the interop and being idiomatic. Idiomatic is the semantics of the thing. And so how does it work? What does deconstruction look like in C#? Because deconstruction is quite possibly an important part of this. What does deconstruction look like in F#? Those are two idiomatic differences. But under the hood, they're interrupting can interrupt the same thing. There may or may not be direct interrupt. We're hoping that there will at least, be.
I'll give you an example. In a language like F#, deconstruction is idiomatic. That's pretty much how you do things all the time. But when we designed pattern matching in C#, we included not only positional pattern matching, which would be much more familiar to someone in F#, but we also included nominal. You use the braces and you have named values because there's a lot more cases about how people use C# that have have lots of names in these cases, and we wanted a way that was easier in some scenarios to work with, and that not always require positional deconstruction. The same thing when it came to designing tuples, and you can probably point out, oh well, they're not the same tuple class as F#. But that's not the point I wanted to make. Is that the tuples in C# have names on the elements. Now they're erased, but the act of having the names, it was much more idiomatic of how people use C#. Now you might just, if you use tuples at all, you might just use them with deconstruction, just the same way you might use them in F#, or in the same way. But you might choose to use them more like a class and dereference everything by name. And so that's why they look different.
And Matt, since we're not talking to language designers here, can you just remind us what erased means? And erasure
means that we have a construct of a type and all its things, but at runtime, it doesn't really exist. It might be, for example, in this document, when I talk about an implementation detail for a union type or a type union, that it's a variable of that type could be one of many disjoint other types that they don't share necessarily a common base type. The implementation might be one where we erase the concept of the union type and it's just represented as object in the runtime.
Okay, so I was going to add a couple other questions that I think are really interesting. So from SwiftCut, concept of unions is a part of algebraic data types. Are you looking into that as a whole? Is that part of the discussions here?
Yes, there's lots of different names for these kinds of things. For example, you might say, oh, the thing I call a type union, some people call a sum type versus a product type. And those terminologies just are so non-intuitive to me, it blow my mind. So I have to describe them in things that make sense to me. So in this document here, I've said, when I'm just bringing together multiple types or instances of types and say that these instances can be stored in a variable, I call that a type union. It's a union of types. And it's in contrary to a union of things that are individually named, like an enum, you just have individual names. I guess people like to call them the tags. So I call that a tag union. And the other kind of type, a union type, is I call a type union. There might be lots of different kinds of implementations of these things and how the different APIs and how you work with them. But instinctively, there's one that's a set of states, and that's a tagged union, and one that's a set of instances or possible instances of different types, and that's a type union, where they don't have names or tags.
Okay.
And Matt, one thing that you just brought this up, and one thing that confused me in some of the earlier conversations about this is some of the lines, connecting the dots with specifically F# unions, and the fact that F# unions are actually tagged unions, not type unions, even though my intuition was the reverse of that. And so they could be implemented either way, but it's my understanding that because of things in .NET, in general, tagged unions are more, they can be implemented with less impact on the broader system, particular performance impact.
Well, it's possible with a tagged union to be performant in a way that a type union might not be performant. And it all comes down to what are the possible ways you can implement them. And a tagged union, obviously keeps a separate state of what variable inside it, what state it's in. And the values it's storing aren't necessarily represented by a type that encompasses them. I think people might not be familiar. If they're familiar with discriminated unions, they don't need to be explained. But the difference is, in one case, an enum is a discriminated union, where the discriminator is the enum value itself. But discriminated unions also can have other state or other bits of data associated with each of those cases. And how those are stored in memory determine whether how memory performant it is. And when those things are an example of a union that is memory performant is you go all the way back to C, and C has unions, and they're just basically sets of values or members on a type that overlay in memory on each other. And so you can only ever have one view of that memory at the same time. So you might have 10 different possible views on that memory, but they don't ever take up more space in memory than the largest structure. It's very awkward to do that in the runtime. There's no ability to easily overlay any type of structure in the .NET runtime. And maybe there will be in the future. Maybe this will drive it so that we can get something that works that way. So there are types that are easy to overlay, and there are types that are difficult or impossible to overlay. And so when you end up with types that are impossible to overlay, like a structure or struct that has both primitives and reference members, you might have strings and ints in there. You can't overlay them with other types that don't perfectly match where the reference types line up and the non-reference types line up.
Well, and how would the garbage collector know if that
exactly? Well, the runtime would just probably completely fail if you tried to do that. And in fact, you can make overlaid unions with some attributes, or structured layout attributes, but there's certain things that are taboo. You might not see it being a compile time error, but a runtime will definitely tell you that it can't run with those things overlaid that way. So when you have a tagged union, with each case, you're not often saying, here's a type that holds all this state that I want. It just, here are the primitives, or here are the pieces. And then the type itself can decide how to store that information, and it can be optimal. When you come to the problem with, you already have a set of existing types, and you just want to say, maybe at a point of a parameter or return type, that this parameter or return type could be one of many possible types. Your choices are fewer, and you can't necessarily overlay them if they're struct types. If they're all reference types, you can say, oh, well, okay, those are easy. I can represent them all in the same spot. But if they're struct types, you can't. And so your best solution oftentimes is just to box the structs and then treat them like reference types, and which may be not useful for a performance scenario you're trying to use it in. So when people say tagged unions are better, there are certain high performance scenarios, you can define the tagged one to be memory conservative and not cause boxing. But you can't necessarily do the same thing with the other kind of union. You either always choosing reference types and causing allocations, or you're causing boxing, which is causing allocations.
And if we look at an example real quick, let's look at result, which is either going to be result of T or error. Those are the two choices. And
Sure.
then in some cases, error can either be of a exception type, or it can just be a string. So for right now, let's just make it a string. And so now it can be implemented as a tagged union, where we have two states, error and result, and there is one place to put data, which is whatever T is. And so now we have a very general purpose thing that can be implemented as a tagged union, so it can be very performant. So a lot of the cases you might think about, especially from F#, you're going to be able, you can handle as tagged unions. And so that's where we're kind of, if I can add one thing, right now, we don't know.
The result type, or the result of T or whatever type can be implemented either way. You could have a type union where you have an instance of a result type and an instance of a error type, and they get folded together into a union. But in that case, you always have to allocate one of the other two. If you make them, structs, maybe record structs or something like that, then can't necessarily overlay, so they might get boxed. If you make it a tagged union, you don't really have these types. You don't have a result value type wrapping it, or you don't have another type wrapping the error state. But because of the other limitations, because of it's a result of T, you don't know what T is going to be. You can't really represent that without just basically making them adjacent in memory. You can't really overlap them because you don't know where it's going to be. So that's a case where you can make it tagged, but you can't make it necessarily memory efficient, but you can make it non-allocating.
And just to be clear, part of the thing that we balance here and work with is the fact that it's very important that T be able to be either a value type or a reference type. So if we consider a discriminated union-like result, I mean, we can't say, well, it's just always a reference type or it's just always a value type. It has to be able to be both, which causes us to have to think about it in a very unified way.
Generics always kind of bring a little bit of trouble when we talk about how to implement things.
Yeah, definitely. So, I wonder if you could just scroll down just a little bit. You've been teasing us with the goals section. It's been on screen.
Well, okay. But the other things down here, there's only a couple main sections of the whole document, and one was recognizing.
But I think the goals are really important. So, can we look at the goals for just a second?
Yeah.
Okay, so this is
what
we're
first goal that we basically decided. These aren't actually. We didn't actually come up and say these are our goals. I'm inferring these from our discussions about what people thought were important. And I wrote them down myself. And so if they don't seem right, it's my fault. But I interpreted from everyone that was discussing them, the most important thing was how do we make people's existing types that are kind of like type unions or kind of like discriminated unions. Maybe they really are. Maybe they're that result of T type or that option of T or the one of type. How do we make that work well with pattern matching? How do they mesh well with a switch statement so it looks like C# when you're using it? The next goal was, well, defining union types themselves, especially those tagged ones that are more useful in performance scenarios. When you actually look at an implementation of one, it's a lot of code per case. It's like you're implementing a lot of functions. And when we looked at things like records and we said it's useful to have a type here that takes a lot of that boilerplate, it's probably also useful for many people to have us have a way where you can describe a union type, tagged or otherwise, and we do the work in the compiler to make everything match what we need for pattern matching or other things we might make the type more integrated with the language with. So that was important too. This isn't saying we're actually doing any of these things, or I'm just kind of putting them in order of I thought I drew from other people what people thought were the most important and what order that was in. And then the last one was just basically, I should be able to make a union over existing types. And this really is recognition of languages like, well, the union types that kind of exist, but not this using these terms in like TypeScript is just a reference to types that already exist. And this statement here is in reference to Mad's earlier proposal from, I don't know how long ago, half a year ago, about doing union types. When we were looking at it before, it was like, well, other languages union types, if C# had union types, what would they look like? And Mad's made a big proposal that says basically type hierarchies. Type unions would be represented as type hierarchies, and you would write them out in a syntax that kind of looked like other languages describing discriminated unions, and each case would just be a type, right? So you've already bought into the idea that you're allocating each of these things, but it didn't talk about any way to take types that already existed. For example, you might want to claim that a member of a class you're writing is one of two types that you didn't write. They came from some other place. Or maybe you did write them, but for other reasons, and you want to constrain a parameter. So you should be able to say, I want this function to take as this argument either a customer or an employee, but they never actually shared a common base type, and it's already pre-existing. and changing it now would be huge, breaking or something like that. So it should be possible to do that. But which mechanism does that, we're not quite sure yet. So those were the goals. Make things work well with pattern matching, make it possible to create union types easier, and let you make unions of types that you already have. And that's basically, they don't have to be declared with a new structure. And then the document gave examples of existing things that look like union types, but C# doesn't understand them as closed, so it can't do the pattern matching the way we want it to. And then there's existing types that third-party people have implemented in many different ways. And some of the examples were these 3 option, result, and one of. And there are others, but we just kind of focused on these because usually people, when they talk about them, they focus on things like this. And so these are the set of pre-existing types that we could improve. And then in my document, I talk about there's basically, at least in my head, there's 2 kinds of these types, 2 categories. And one is the type union that I talked about before, and one is the tagged union. But these still aren't implementation details. And then the final thing, well, then I have a piece here saying that in languages, say like TypeScript, you don't actually necessarily give names to these things. They can be just represented as syntax, the way like a tuple can be represented as syntax, and you didn't really give that a name.
Mm-hmm.
So some are named, sometimes they're named, sometimes they're not named. And then I have a whole section on here of things that we can make it possible. What would we need to do to consume those existing types like enums and type hierarchies and pre-existing types like one of and result of T. And then so I'm just going to skip over it right now. And you might want to ask about these things. And there are some examples in here. But the last whole section is, what is talking about if C# had its own built-in union type for you to make these types and have it generate stuff for you. And what are the possible options for us to do that? Or at least what we talked about so far. And that's basically the whole domain of the document.
All right, so we have a couple of questions here. So let me see if I can find this again. So how about this one? And I'm going to answer this in 2 ways. Okay. So first of all, yeah, sure. Go to C# Lang, see if there's already a feature request, either a discussion or an issue, and weigh in on it. So yes, it's absolutely a time to talk about it. Is this talk today the time? Probably not, because we're probably, sorry, let me just take that off. Oops, wrong one. It's orthogonal to this particular proposal. So this discussion today, we probably won't talk about a nothing type, but if we, once we get more implementation details on discriminated unions, then I think how you're going to represent nothing in them may naturally fall out. It may just be, an option where it's maybe a none or some and none. But
I think maybe they're referring to a nothing type, like a unit type.
Yeah, unit type,
yeah.
Exactly. So yeah, so I think that yes, in C# Lang, probably not today. And they also point out that in some sort of either or option is important.
I think we lost Kathleen.
I think we did.
Oh, there
She's back.
Wow, I didn't know that we lost me. Okay, so I had another one.
Well, you looked for that. I had one that was slightly unrelated, but I'll throw this one up as well for Matt. More in terms of like where you're getting inspiration and what things are you looking at. So TypeScript union type mechanism is easy to use and understand. So something close to that would be wonderful.
It would.
We agree.
I agree.
And this is a comment on why we're having the conversation. So we know that that people that work in other languages have a real pain point when they come to C# and they're missing their unions, and that's true both if they're coming from TypeScript and want a TypeScript style union, or if they're coming from F#. and want the F# style union, which I can tell you, I just review them in C#. I make some sort of fake it kind of thing that's not as good, just because I can't live with that option and result, particularly result. So I just make it so I can fake some functional things.
Someone over here has asked a question about roles and extensions.
Yeah, I was just going to bring that one up. So
It's interesting because Mads just was talking about that yesterday in the language design meeting about how some things in the extension proposals could be used to solve some of the problems in some of the union type cases. And well, it's not necessarily certain that that's true, but it was interesting to me that someone else is asking that. These things aren't necessarily related, but only maybe related in the sense that the team can only do so much at once.
Right. And at this point, we do not have a reason to believe extensions have to ship first. But when we get to implementation, we might feel that. And also, from a shipping point of view, I am not optimistic. We have a lot of work to do because the reason we haven't done discriminated unions yet is it's hard to get them right, and we're not going to do them unless they're right. And we think we have the right journey ahead of us to get there. And it could be that it comes in phases like pattern matching is, and we do get a first step in as C# 12, at least in preview. But I'm not, at this point, there's no reason to think that this is a C# 12 conversation. We're certainly having it as a long-term, we are committed to this journey kind of conversation, not a, how do we make it fit in C# 12? That's just not our conversation right now.
I do know that I don't get to decide that. So,
yeah. But
none of us.
What we can do is make sure that people have all the facts and choices being made before.
But if you read all the way to the bottom of this public discussion, so you should scroll to the very bottom of your public discussion document, Matt. Just if.
Okay. Very, very bottom. Is there something new there now?
No, it's something you wrote.
Okay.
Not in the comments. The last thing in yours.
Oh, the last thing in the document itself, not the comments.
Yes.
There's been a few comments.
Sorry for the scrolling.
What feel free to weigh into. And if you don't know, Andy Gaki is commented in here. He's one of the people who wrote one of the other proposals. And it's not competing proposals. Everybody's building on everybody else. But
Andy posted. I think he was impatient because when we talked about the document last week, we kind of ran out of time and weren't able to discuss some ideas and thoughts that he had. And we redid that yesterday. But I think he was a little impatient and was feeling he didn't have time to actually partake in the working group. And they wanted he just had a lot of stuff in him he wanted to put out. And it's really good feedback. And so when we pick up the working group again soon, we can go right into the stuff he's provided for us, and we can talk about that as well. Okay, so here's the end of the document. Is this what you're referring to?
That's what I was referring to.
Oh yeah, that's right. I'm sorry I had forgotten about this. You can go kick the tires. Thank you so much, Bill, for remembering this is out there. So yeah, you can go play.
Okay, so I want to point, if you go do play, it's complicated to set up, and it's not a preview of C# syntax. There's no compiler changes there. It's just a project I made for, it includes a source generator, so I could type out and generate union types, tag unions, type unions, and however I thought at the time that they might be implemented. And so I could take a look at, you basically could type out your favorite tagged union or whatever, or result of T or whatever, and then you can go look at the generated source code and see how much did it actually have to implement. And then I use this for cases where I could change the whole implementation of the source generator and see if I can make it more efficient and things like that. And so it was here again, this was posted for the other members of the language design team if they wanted to see how the examples I'd been talking to them about, how they were implemented. They can go run this and see it. But anybody could use it. And but it's just a point in time. It's not necessarily how I think we'll end up with the implementation of a union type.
And it's to play with ideas. So don't go put this in your production code. It's not. That's not the intent there.
No. It's not a
If you're
library
doing
for people to use.
something else right
instructions
now,
on.
Yeah.
like creating your own result
Like,
type.
I have an implementation of a one-of type, not the ones that exist out in the wild, but just my version of it that kind of conformed to how I was thinking how a pattern in the API would work. And then to compare it against other implementations of custom generated types versus the one-off types.
Mm-hmm. So I also saw this one that I think is certainly on the table as part of the design.
You want to comment on that because it's actually a little bit more. It's a good question because
that's a good question.
Yes.
Every time that I model a union type or code gen, I do actually implement those.
Well,
that's what I was saying. A lot of the document that I wrote deals with how those types that exist, what patterns, what attributes or whatever could cue the C# compiler to know about how to do pattern matching. But then there's the case of going beyond pattern matching. What else could we do or what else in the API of types could exist that could make it easier to feel more like C# and that you're not just calling an API. And some things like equals working would be one of them, and toString just having a correct behavior, and you not having to switch over it just to get the right, or just to get maybe a correct debug string. So yeah, those I would assume end up in there. We put them in record and tuples, so I think they'll have an implementation.
Right, but we'll have to work out details, like value in reference types or the quality of the underlying type, and result of T equals result of T. What's the equality? Does the result run the quality? Does the type run the quality? And so I think we'll have a few little details that will probably land on the simple answers on all of those. But there's a few questions we'll work through later when we kind of get the general sketch a little bit. We have a proposal, yeah. So one thing I'd love to get in the chat, if there's anyone who has unions, they want to make sure that we keep in mind other than the ones we've listed. So result of T, and then result also of T and E, and option and one of. Those are clear things we have in mind. One of is quite different than the other two, but because there's a dot in the generic list. So those are very much on our radar. Taking things that you already do, like enums. And so, for example, elsewhere in this document, talks about, like, should we allow string enums? Should we allow other things that are, other types to be enum-like? So there's some other aspects there. And so if you have some scenarios, I'd love to bring some of those up. And if you have another kind of DU that you're used to doing. Smart emus? You mean
that brought in an interesting question.
What? I'm sorry.
I believe that's smart enums, not smart emus.
Oh,
I think that Java smart enums, I think it's just is a tag union.
Okay. Yeah. Yep.
And I'm going to blame that on autocorrect. But
yeah.
I love it. I would like to know about smart emus too.
Yeah. Okay. Single case unions. Oh, wait. We ran over each other.
We ran over each other again. Sorry.
Single case.
I'm not sure what that is.
Oh, it's enum single case.
You mean enum cases that are basically singletons when you're talking about them being types?
I think we want to know. That's a great. Thank you for bringing that up. It's exactly the kind of thing we're asking for. And if you have an example of why you want that, that'd be great. Because as some of you know, we don't have single case tuples, so we don't have wumples, and so that it'd be great to understand, so we can prioritize that. It's not in my mind right now, Matt. I don't know if it's in yours.
I'm sure.
With the single case.
I'm not sure what the example.
I think he has an example here, or something like that.
You actually just having one case. I mean,
yeah.
Well, that's not. I don't think that's one case though. That's one Oh, yeah. Okay, got it. Yeah, it would be help with deconstruction. Yeah, we ought to think
Yeah,
about that.
I haven't thought about it, but I'm sure we can add that to the things to think about.
The thing I wonder about that is that this is really nice syntax in F# to be able to define the deconstruction in a very natural way. And so for F#, that is the right answer, because as you said, F# is like all about deconstruction. And for C#, we kind of do deconstruction right now with a little bit more ceremony. And so whether making unceremony in deconstruction in C# is something that we want to include in this, I'm not sure about that.
There's a question here about which type of union would take precedence.
Yep.
I'm not quite sure what the meaning of precedence. Do you think, is that precedence over which would be delivered first if we were doing both? Or is that something in the language itself if you had an instance of one of each? I'm not quite sure what it's asking about.
Yes, that may need some more clarification. I put that one up in part because I wasn't sure I understood the question either, but it looked interesting. But I wasn't sure I understood exactly what was meant. So if you can clarify that, Obina, I hope I'm pronouncing that correctly, but thank you.
I could answer both.
Yeah. We can go back to the previous question.
The fact that there are multiple kinds may mean that we do both, or we do one, or of them, and that choice is not currently being made. If we're doing both kinds, there probably will have some implementation or choice about which one we would do first over the other one, or
we don't know.
But it's only as far as I'm concerned, my job to make sure that what we're talking about can be broken down into optional steps for shipping.
Yeah.
And not just one giant monolith.
Yeah, can we flip back to the other question, because we did get a good example of why. No, that's not the right one.
You wanted the smart.
They keep moving.
Yeah.
Now they said can't be ixed with other int. That's in relation to the customer number being a customer number of int.
We'll find that one.
Yeah, so this is related to this one. Okay, so in this case, then a customer number now is not an int. It is.
They're using this a union model as a way to kind of give a unit to, they're basically wrapping it.
Like units of measure a little bit.
Giving it a name.
Yeah.
Like
so it's not exactly, but yeah, no, that is interesting, and yes, we do that in F#, and yes, it is very useful in F# because F# is deeply committed to correctness if it compiles, it's probably going to run correctly. That is a core part of the way F# was designed, and it's not in C#. And so that is a difference. And so I don't know that this is a C# thing, but I really appreciate it being on the table here. And thank you very much for bringing that up. There's another one here, which is an idea, based on, hey, what else did you want to tell us, folks? And it's this one. It's being able to declare methods, and it kind of goes further. Do we expect the members of a discriminated union to be able to have methods? It's not something I've thought about.
It's possible. We didn't discuss that specifically. It kind of was discussed in Matt's proposal, because his proposal was they were all just a type hierarchy. But I would point out that a goal of ours is to make sure that your type hierarchies are understood as unions in the right places if they're closed. Right? There's a way to declare them as closed. So there's always a fallback if you want to have methods on things that you can make a type hierarchy and use that as a union. That should always work.
Okay.
I'm not sure what it would mean, for example, to have custom methods on a tagged union, because they never represent as separate types.
Okay. All right. Let's. Well, somebody says that F# code never works when it compiles, so I'm going to take that back.
I don't know how to answer that one.
Well, it's just the design of it is that you're not going to have an integer wind up, and a customer number and integer are not going to get mixed up. That in the case that we were just talking about. And this is a question we also don't know the answer to, and I definitely look forward to your feedback on it. So this is, we work hard to not expose our org chart more than necessary. However, we do have different teams because that's the way we work. And we're specifically today talking about C# language design. And we work very, very closely with the runtime team. But if there was a standard result type, that would be something the runtime team thought was important to build on top of the language feature. And you can look to generic math for that. So the language design team wound up putting the underlying features in place, and then the runtime team wound up putting in the actual types. So if we made these types, then they would definitely be that would be a decision we would make later after we understood. And I know those people, so I know one of the things that they're going to look at is whether the oh no, sorry, I just messed us up. Okay, sorry, let's do that. Let's get back to, that's where we want to be. I just wanted to get Bill out of here, and I totally blew it. So yeah.
Can I say that it is a focus of the working group and represent the document that the primary focus that we have is to make it possible to use existing types. So all those types you might have from third-party libraries that will play nicer in the newer version of C#.
Right.
And
yeah,
if someone else in Microsoft in .NET decided that .NET needs its own version of these types, then that's kind of a orthogonal issue.
And I think I didn't finish my sentence. Where I was going before I messed up our show there was the runtime people aren't going to do it if it's not performant. They're not going to encourage you to do something that's going to hurt your performance. So I think we would have to wait to see an implementation before they would make a decision about whether or not they were going to do that. But it's a great question. I hope we do have them, because I don't want everybody having their own, and I'd like to be able to interact.
There's also the case that when we do have, say, a C# syntax for declaring types, and we have one of the possible ways of implementing a type union is basically it's just syntax sugar on top of a type like one of. And if we would chose that, then I would assume that there would be the one version that the C# knew about that it would be targeting with the sugar, as opposed to anyone. So, but then I might be wrong too. I mean, it might be another way where you can slip in your favorite type to take the place of the implementation detail. But there's lots of different implementation choices for that one. So I'm not sure that is even the choice we'd end up with.
Yep. So one thing we haven't talked about, which I don't know if you want to go there or not, but you did have some examples of some anonymous unions. Do you want to chat briefly about anonymous unions? Or do you want to let people read your document later? I don't know how big it is. I think we got 5-ish minutes. And then things. Well, we've got 10, but I want the last 5.
Oh, okay.
When we talk about a named union in the document, it's talking about when you're declaring a union using whatever syntax C# would have. And I could scroll you to where I propose a working syntax. And this syntax exists is not because it's the best syntax. It's the syntax that exists so we can talk about things without rat holing on syntax. And it's way up here. This guy right here, this syntax describing how you might declare a type union, and the one down here, how you might declare a tag union. And this is not meaning that I expect there to be a union keyword in the language, etc. But this is so that we don't talk about the syntax. We can talk about the features and write them out, and everyone can agree and understand what they're talking about without us talking about syntax yet. And an example of an anonymous one would be this first one up here. Here's a union. I said I want a string or an int, and maybe I'm doing that for a field in some class I'm writing, or as a parameter or a return type, and I'm saying it without actually giving a name. I'm not necessarily creating a type specifically to represent string or int when I write this out. And so this is an alternative to pre-declaring one like you might in C# saying, hey, there's this new type and it represents a string or int, and this is its name, string or int. Does that make sense?
Yes, that's great.
And then the document I do talk about cases where that might be useful, like the examples I gave. Maybe you have a case where you want to restrict a parameter of a method to just a few cases, and it's just simpler to just write those cases like you might do with TypeScript without actually necessarily coming up with a name for it. That might be an annoyance to have to name everything.
The one that caught my attention is the first in the tag union, which is just being able to say, look, we want yes, no, or maybe here. That's all we want.
Exactly. So I basically said syntax. With the syntax I provide, you could also write out a tagged union that way. The default case without anything carrying any extra data just looks like an enum here. But it's using this other syntax, so we can say, oh, I know this is a union. I know it's a closed set. I expect the compiler to behave a certain way when I have this type versus the existing enum type. The actual syntax the C# might end up for a closed enum might just be using the sealed modifier on an enum. So it might not be this syntax at all, right? So that's like one possible choice. But then I kind of do point out later that oftentimes when you have tag unions, they might have lots of more cases. And because you don't, when you have a type union, the values that you're talking about are types that already exist, right? If you say a variable is of type string or int, you can assign a string to it. You can't construct a tag union without naming the tag union. And so not having a name for a tag union means you have to write out that name every single time to just instantiate an instance of it. So that might be impractical, or people might not care to ever want to have an anonymous version of that kind.
Yep, we have a couple of questions about the language design team that I want to bring up really quick. I'm just looking for them. One of which is minimal API will benefit, and I just want to make sure that y'all know that we have minimal API people that.
The minimal API people were represented in the working group. Yeah.
Yep. So we keep a good tight on that, and then the how do you get to the language design team? So our notes are at C# Lang. Our meeting notes are there. We definitely love sharing what we do. It is a closed meeting for some good reasons and historic reasons both. But we make so many mistakes there that it would be very, very confusing if we showed that meeting. It is not like the API review where everything's kind of boxed up before you go to API review. We look at the most raw early ideas we possibly can, and 90% of them are wrong. And so we do it in the meeting notes. And I'm probably exaggerating at 90%. You can watch our meeting notes and track.
Strangely enough, when we first started making the design process public on GitHub, we were planning to actually broadcast, all of the meetings. And that seemed good to a lot of us, but it didn't make everybody comfortable. And so we eventually abandoned it because we want the meetings themselves to be more inclusive. And we do actually often bring in people from the outside when they're championing things. And so people will phone in or connect in we're using Teams. And so we get a lot of other people coming into the meetings too, but they're just not packaged as in that way. We just package them as the meeting notes.
Mm-hmm. And then somebody pointed out that, yes, it's always interesting to do overloads. So yes, overloads will be interesting when we get there. And so they're always interesting. And then it's always interesting to Bill to write about them because Bill takes care of our docs. And so does he get a say what they are? Then
that's a good question. This is a method overloading resolution, and we love to have to write about that in the language spec.
So there is, if you look at the .NET/C# standard repo, we're going back through catching up on betterness and even betterness right now. So and honestly, working on that with other people who really care about how the language is
I would assume
documented.
The answer to this question, though, is how the language normally works when it's picking out which method overload. When the target type of a parameter is narrower, is the most narrow, is usually the one that's picked. It gets more complicated when you have multiple parameters and they go different ways. But so
And,
the example
and
here would probably end up picking
string.
the first one.
And
Well,
it's
string if it's a string if it's a string, and there is no integer overload, and string or int if it's known to be an integer. So it would be the narrowest we can do.
Well, we
And
also
we'll
have
to
to
just think that through further. But that
But
would
I would just tell you not to have these overloads.
Yeah, no, because it would also depend on if A was in a derived class, if the second one was in a derived class, and the first one was in a base class.
Yes, thank
We'll
you.
look in derived class, in the most derived class based on the compile time type first.
Right.
Yeah, usually it takes
C#
the set's defined at the layer that it's in.
Yeah.
So C# starts at the most derived, and if it finds something, it never looks higher. So so there's definitely overloads.
So the point is, yes, we will be updating this part of the spec to deal with whatever does actually come out from all of this work. It will have impact there.
Yeah. Well, I'm wondering if we can jump to a couple of announcements before we say goodbye. Are we getting to a spot, or do we have some more questions that y'all are saying that we really want to get on before we?
I have not tagged any others that I saw. I did add to chat where the LDM notes are for people that do want to comment on any of the notes. There's a PR for each new one that comes out, and you can add comments as well at that time.
Great. Okay. And if you C#lang is our source for conversations. This conversation is there. I'll also add in, Bill, maybe you could bring this up for me. The another one that we put up there this week, which we'd really love you to read and consider, which is we have had a position that's painful around keywords and breaking changes. And so if you look at, if any of you saw the when Jared was on, and Jared did the async thing, that is because of how we chose to manage async as a keyword for backwards compatibility, and for the fact somebody could have had a type called async all lowercase. Now we're doing some things about that, including saying that all lowercase type names, we're kind of setting those aside and saying we may use those. So please don't use all lowercase type names in your work without recognizing that. But we also need a little bit more. We just want to know. We want to know what people think. And so we have a proposal for a way to consider doing breaking changes. There's an example, which is the field keyword, which currently is in semi-auto properties. The other thing that I want to mention is that we have a feature status page, which I'm going to put into the chat as well. And the feature status, you can also find that. I can tell you that I never remember that link. I just type into my search engine, Roslyn feature status as 3 words. It always takes me there. That is not on C#lang. That's in Roslyn. And the reason is that we do work in Roslyn and we dream in C#lang. And so that's the difference between these. So when something becomes a real proposal, we're ready to go forward, then it's important we move it into Roslyn, and we do track them in Roslyn. And so we have 2 things that are coming up that we're super excited about. One is primary constructors are scheduled for 17.6 preview 2. We do all of this work in the open. So the feature status, that 17.6 preview 2, that's actually in the feature status page. That's how we know that. And all of us do our work off of that. So, whether it's Bill setting up for docs or me setting up communications or talking to you about it, then that's where we go. It's our source of truth. And then also we have alias any type is, I think, what we're calling the feature that's coming out in 17.6 preview 3. And so we know that we don't have stuff in preview 1. And I want to comment on that, because if you've been watching us for a while, you may have seen this, or you may have not noticed. I don't know how closely you watch us. So our year has developed a very, very serious rhythm. And so in November, we get out the release, and then we spend a lot of time thinking. We do working groups. We do big thinking. We figure out the scopes of what we can and cannot do. That's always very fluffy at this point. And that goes through sometime in January. If we have a feature that was ready but didn't quite make it, then we may get it into preview 1. Also, if we have something we know to be contentious and we're ready to go, like Bang Bang was, we'll get that in preview 1. And then we work to get things ready, and preview 2 is likely to have things, and then preview 3 will be kind of where you're going to see more stuff. So that we just kind of have this year. So preview 1, yep, didn't have anything for C#. Preview 2, yep, it's going to have some stuff, and not sure it's going to have a lot, but there'll be a little, and then preview 3 will have more. So yeah, any questions on that? Yeah, somebody commented on the async thing being in your code base is terrifying. Yes, I agree. That is terrifying. We're not sure we wouldn't mind avoiding ever doing anything like async again. We wouldn't mind that. So yeah.
Right.
So yes, there's some controversy on primary constructors. There is a discussion. So yes, you can go talk about that. Yes, this is true. Okay, so I think we're about done.
I think we are at time, but I will.
Okay. And
What's
Matt?
the date for primary constructors? I don't have the date, but it's when 17.6 preview 3 or preview 2 ships. I don't have the date in front of me.
Yep. I'm sorry about that. It's upcoming.
Yeah.
Matt, you are awesome. Thank you so much for joining us today, and thanks so much for this work. And I encourage people to just take your own position on this. Either read this and play with it and get serious about it and give us feedback, or say, can't wait to see what you do. Looking forward to seeing a real proposal. This is a little bit of an experiment for us to bring something to you quite so new. It's very, very fresh for us. And so if you like that or don't like that, feel free to tell us in the comments. Yep. Matt, do you have anything you want to say in signing off?
No, just thanks for having me. Get to be a celebrity for a few minutes.
Yeah, that's always awesome.
Celebrity.
And thank you. And with that, we will see you next time.